I am teacher CJ and I will be your science teacher for today's video lesson. The Philippines frequently experiences earthquakes. And you might see in the news that these earthquakes have what we call as epicenters. Today, we will figure out how to locate earthquake epicenters and also talk about plate tectonics. Today, we will explain the plate tectonics theory and locate the epicenter of an earthquake using triangulation method. Before we start, answer this 5-item quiz. Choose the letter of the best answer and write your answer on your notebook. You can pause the video if you need more time in reading. Let us start. 1. Which crust is thinner and denser? A. Earth's crust. B. Oceanic crust. C. Continental crust. D. Lithospheric crust. 2. What type of rock comprises the continental crust? A. Aluminum. B. Basalt. C. Granite. D. Iron. 3. What theory states that the Earth is divided into slowly moving plates? A. Bose tectonics. B. Wegener's theory. C. Plate tectonics theory. D. Seafloor spreading theory. 4. What is the fastest type of seismic wave that arrives first in a seismic station? A. Body wave. B. Primary wave. C. Surface wave. D. Secondary wave. 5. At least how many seismic stations are needed to locate the epicenter of an earthquake? A. 1. B. 2. C. 3. D. 4. To start, let us have these important terms and their corresponding definition. Earthquake, vibration of the earth due to the rapid release of energy. Plates, rigid section of the lithosphere that moves as a unit. Seismograph, a record made by a seismograph. Seismograph, a device used to record earthquake waves. Seismic station, a station recording movement of the Earth's surface caused by earthquakes. Lastly, mountain range, a group or chain of mountains located close together. Are you familiar with the picture on the screen? That is right, the Mayon volcano in Albay. Have you ever wondered what caused the formation of this majestic spot? This lesson might shed light on that. Today, we will talk about plate tectonics. Earth's lithosphere consists of layers, the crust and the upper part of the mantle. The crust is made of a variety of solid rocks like sedimentary, metamorphic, and igneous. It has an average density of 2.8 grams per cubic centimeters and its thickness ranges from 5 to 50 kilometers. The crust is the thickest in a part where a relatively young mountain is present and thinnest at the ocean floor. In the picture, we can see that the continental crust is thicker but less dense, while the oceanic crust is thinner but denser. The continental crust is mainly made up of silicon, oxygen and aluminum, calcium, sodium and potassium. The thickness of the continental crust is mostly 35 to 40 kilometers. Continental crust found under land masses is made of less dense rocks called granite. The oceanic crust is around 7 to 10 kilometers thick and has an average thickness of 8 kilometers. It is found under the ocean floor and is made of dense rocks which are basalt. The oceanic crust is heavier than the continental crust. Do this. Direction. Identify what type of crust is described in each item. Your answer should be either continental crust or oceanic crust. You can write your answers on your notebook. 1. Made of relatively younger rocks. 2. Composed mainly of basalt. 3. Granite rocks are found. 4. Makes up the continents. 5. Relatively denser but thin layer. 6. Thick in volume and less dense. The picture on the screen is a map of plate boundaries. The Earth's lithosphere is composed of different tectonic plates which are adjacent to each other. Some are oceanic plates and some are tectonic plates. What is plate tectonics? Plate tectonics is a theory which suggests that the Earth's crust is made up of plates that interact in various ways. There are 7 relatively large plates, namely African plate, Antarctic plate, Eurasian plate, Indo-Australian plate, North American plate, Pacific plate, and South American plate, and a number of smaller ones. The plate moves very slowly and constantly. Plates move away from one another, towards each other, and sliding each other. Which leads us to the question, what happens when the plates move? And the answer is, geologic features are formed such as volcanoes, mountains, and earthquakes occur. Let us first talk about earthquakes. When earthquakes are reported in the news, you would often hear the term epicenter, just like this news article from CNN Philippines. An earthquake with a magnitude of 4.2 happened in Bohol last August 11, 2015. It is further stated that the epicenter of the earthquake is located 2 kilometers northeast of Cortez. You might be thinking, how are epicenters located? To answer that, let us review what you have learned in your grade 8 science lessons. You discussed that an earthquake releases 3 types of seismic waves. We have primary or P waves, secondary or S waves, and long surface waves or L waves. P waves and S waves travel into the Earth's interior, while S waves on the surface. These waves travel at different velocities, thus do not arrive at the seismic recording station at the same time. The difference in arrival time will tell us the distance of the earthquake from the seismic recording station, but it does not tell in which direction it came from. So, what workaround can we use to solve this? The solution is employing triangulation method, wherein it uses at least 3 recording stations to locate the epicenter, hence the name triangulation. The next activity will show you how to do this. Activity: Find the center. In this activity, our objective is to locate the epicenter of an earthquake using triangulation method. The materials needed are the hypothetical records of earthquake waves, which is already in our table here, Philippine map, this one, and drawing compass and ruler. Let us start. Procedure number 1. Study the data showing the difference in arrival time of P wave and S wave on 3 seismic recording stations. We have Batangas, Puerto Princesa, and Davao. In our table, we have here already the time difference in the arrival of P wave and S wave, which is in seconds. For Batangas, we have 54.4 seconds, Puerto Princesa 32 seconds, and Davao 38.4 seconds. As you can see, our third column here is empty. In order to fill this, we must proceed to procedure number 2. Compute the distance of the epicenter from each of the stations using the formula. D equals TD over 8 seconds times 100 kilometers, where the D is the distance in kilometers and the TD is the time difference in the arrival of P wave and S wave, which is in seconds. This formula is suited because 8 seconds is the interval between the times of arrival of the P and S waves at a distance of 100 kilometers. Let us try to solve the distance of the epicenter from the station in Batangas. Using the formula, D is equal to TD over 8 seconds times 100 kilometers. So we have here D equals, the time difference in Batangas is 54.4 seconds. We will write here 54.4 seconds over 8 seconds times 100 kilometers. We can cancel the seconds here so that the remaining unit will be kilometers. Next, executing the operations, this will yield us 680 kilometers. Therefore, the epicenter earthquake is 680 kilometers from Batangas recording station. We will write this one in our column. So we have here 680 kilometers. No need to write kilometers because it is already indicated here. Performing the same for Puerto Princesa and Davao, this will yield us 400 and 480 kilometers respectively. Now that we know the distance of the epicenter from the different recording stations, let us proceed to step number 3. Choose one of the recording stations and measure the computed distance on the map scale. The scale of the map is 1.5 centimeters is to 200 kilometers. Set your compass for that computed distance. Now that it is impossible to measure 680 kilometers and put that in our map, we need to scale it down. So in our scale, we have 1.5 centimeters is equal to 200 kilometers. We will apply that one. So we have, for Batangas, we have 1.5 centimeters over 200 kilometers is equal to, let us put here X for Batangas, and 680 kilometers. Performing this one, we have 200 kilometers times X is equal to 600 kilometers times 1.5 centimeters. Performing this one, we will get X is equal to 5.1 centimeters. Therefore, in our map, 680 kilometers is equal to 5.1 centimeters. Let us put that in our table. Again, 680 kilometers is equal to 5.1 centimeters in our map. If you do this with the Puerto Princesa and Davao, you will get 3 centimeters and 3.6 centimeters respectively. Now that we know the distance of the epicenter of the station in centimeters in our map, we will now plot this in our map. So this is our map. Our first station again is Batangas, which is 5.1 centimeters. We will get our ruler and we will measure 5.1 centimeters. So we have here 5.1 centimeters. And then we will make a circle with the tip of the compass pointed at Batangas. So we now have our first circle. This means that in any of these points in the circle, those are the possible locations of the epicenter. We need to pinpoint the epicenter, so we will need a second recording station. Let us go back to our table. For Puerto Princesa, we have 3 centimeters. Again, we will measure 3 centimeters in our ruler. Measure 3 centimeters and then make a circle. The tip of the compass pointing at Puerto Princesa. Let's make a circle. Now we have the second circle. As you can see, there are 2 intersections of the 2 circles. That means that either of these 2 is the epicenter of our earthquake. In order to pinpoint this into one epicenter only, we will need a third recording station, Davao, in which we have 3.6 centimeters. Again, let us measure 3.6 centimeters in our ruler. We have 3.6. Okay. We will now put the tip of the compass in Davao. So we have here Davao. And then make a circle. As you can see, there is one intersection of the 3 circles. The intersection of the 3 circles is our epicenter. For our procedure number 6, circle the epicenter in red. Again, the epicenter is where the 3 circles intersect. In this case, the intersection is at Hulo. Therefore, our epicenter is at Hulo. After watching the video, answer these guide questions and write it on your activity notebook. 1. Where is the epicenter of this hypothetical earthquake? 2. Which province on the map is closest to the earthquake epicenter? 3. In which of the 3 provinces listed in the data table would the seismograph detect the earthquake first and last? 4. What do you think is the importance of determining the epicenter of an earthquake? If you want to try for yourself how to locate earthquake epicenter, you can download and print the activity sheet using this link. Keep this in mind. According to plate tectonics model, the entire lithosphere of the Earth is broken down into numerous segments called plates. Each plate is slowly but continuously moving, giving rise to volcanoes, mountains, and earthquakes. Earthquake epicenters are located using triangulation method, which uses data from at least 3 seismic stations. Now, let me show you a map of earthquake distribution across the world. The red, green, and blue dots represent earthquake epicenters. You will notice that there are clusters of earthquake epicenters that extend in a line. Why is this so? Now, I want you to compare it with the map of plate boundaries I showed you earlier with the map of earthquake epicenters. What can you notice? That is right! The earthquake epicenters are mostly located along plate boundaries. Now, let me show you a map of active volcanoes across the world. The red areas represent presence of volcanoes. You will notice that the volcanoes form a belt or a ring. This area is known as Pacific Ring of Fire because of the number of active volcanoes present and frequent occurrence of earthquakes. Now, let us compare this again with the map of plate boundaries. What can you notice? That is right. Most of the volcanoes are located along plate boundaries, especially along the boundaries of Pacific Plate or in the Pacific Ring of Fire. Now, let me show you a map of mountain ranges across the world. The orange portions indicate the mountain ranges. What can you say about its location? If we put it side by side with the map of plates, we can see that the mountain ranges form at the boundaries of tectonic plates. Keep this in mind. Plate tectonics give rise to several geologic features and events such as volcanoes, mountain ranges, and earthquakes. Earthquakes, volcanoes, and mountain ranges are typically located at the boundaries of lithospheric plates. Now, I want you to reflect on what you have learned through this video lesson by completing these sentence prompts. Write your answer on your notebook. To assess what you have learned, answer this 10-item quiz. Choose the letter of the correct answer and write your answers on your activity notebook. You can pause the video if you need more time. Let us start. 1. Which rock comprises the continental crust? A. Aluminum, B. Basalt, C. Granite, D. Iron. 2. What is the second wave you feel when there is an earthquake? A. Body wave, B. Primary wave, C. Surface wave, D. Secondary wave. 3. Which crust is thinner and denser? A. Earth's crust, B. Oceanic crust, C. Continental crust, D. Lithospheric crust. 4. What theory states that the Earth is divided into slowly moving plates? A. Bowles tectonics, B. Wegener's theory, C. Plate tectonics theory, D. Seafloor spreading theory. 5. What is the fastest type of seismic wave that arrives first in a seismic station? A. Body wave, B. Primary wave, C. Surface wave, D. Secondary wave. 6. What is the wave that can travel through the Earth's inner layer? A. Body wave, B. Primary wave, C. Seismic wave, D. Secondary wave. 7. You were provided with the data showing the arrival time of the P and S waves recorded from 3 seismic stations. Which of these can you possibly determine? A. The damage to the focus, B. The location of the epicenter, C. The intensity of the earthquake, D. The distance to the earthquake. 8. Which is or are likely to happen when the countries are lying near the plate boundaries? A. Typhoon, B. Earthquake, C. Volcanic eruptions, D. Both B and C. 9. From the seismogram, the distance to the epicenter can be determined by measuring blank. A. The speed of the surface wave, B. Arrival time of the surface wave, C. The difference in the arrival times of the P and S waves, D. The ratio of the amplitude of the largest P and S wave. And number 10. Which of the following best describe continental crust? A. It is the thinnest layer, B. It is made of granite rocks, C. It is made of thin and dense rocks, D. It is made of a younger layer of rocks. Congratulations on finishing the lesson! Now you know what plate tectonics is and how to locate earthquake epicenter using triangulation method. Don't forget to turn in your answers to your teacher for checking. Thank you for watching. Till next time. Bye!